Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is one MCQ about Silane. You can see this is Silane. So the question is in front of you. I request you student, please pause the video, read the question carefully, try by yourself, and whatever answer you get, please write in the comment box along with few words explaining the answer. And don't worry, after some time we'll get the right answer with explanation. And by the way, remember one statement: self-evaluation is essential for improvement. So that's why you should try yourself first. I believe you have tried by yourself, so it's my turn to give you the right answer. Now, as usual for MCQ, two things are very important: what reagent is given and what condition. So if you look at this molecule has four chemical four side of chemical reactivity. One is this ketal linkage, acetal or ketal. This is actually ketal. So point number one, ketal. Second is this ester. Third is this alcohol or phenolic derivative, and fourth this aromatic ring. So if you look at this molecule, this silane, triphenyl silane, it is actually a hydride source. You may consider the borane analog type. 1 point. Second, this C₆F₅, this is student a very strong Lewis acid. It is very famous Lewis acid and utilized in a concept of frustrated Lewis acid base pair. By the way, I have already discussed a dedicated lecture on this, so please visit if you have any doubt about this. But remember student, this concept is little new, so I suggest you to read the video once. I shall provide the link in the description box. Now let's start the mechanism. So if you look at this molecule, boron pentafluorophenyl borane, triphenyl borane. So this molecule, student, is very electron deficient. Why? Because there is no hydrogen in the aromatic ring, all are fluorine attached, and we know that fluorine has two types of effect. One is minus I effect, another is plus R effect, and obviously since it is an halogen, so minus I effect predominates over plus R effect. So you can consider this C₆F₅ group is actually a electron withdrawing, and we know this central boron atom is actually a sextate or 6 electron species, means it is electron deficient or Lewis acid. But if you compare simple boron other reagent like Bf3, what is the difference? These three bulky groups are surrounding the boron. So it is electron deficient, but it is sterically protected. Consequently, every molecule cannot approach to the boron center because of these three bulky C₆F₅ group. So here, who can approach this boron center? Obviously the atom, first of all electron rich, second smaller in size, and this oxygen means OH perfectly matches. You can see this AR means this rest of part, because the main reactivity is happening on the OH side. Okay. Now, so first these Lewis acid base adduct formation happened. This lone pair will be donated to boron and Lewis acid base adduct formation. After the donation of electron pair, the central boron atom will have a formal negative charge. Not only that, these OH bond now became relatively more polar. What do I mean by the statement? See, this OH bond is polar, we know, because the oxygen and hydrogen both have electronegativity difference. So we can understand this is delta positive. Now after electron donation by this, means lone pair of electron donation to this central boron, what will happen? A electron deficiency will be created on oxygen atom, or oxygen is carrying a positive charge, electronegative atom carrying a positive charge, means this atom is more electron deficient, so it will pull the bond pair between this hydrogen and oxygen more. So you can consider that this hydrogen will become more polar, so double delta plus like that. More polar means you can consider this is became more acidic. Okay, as why a particular compound is acidic? Because of polar OH bond, that's why it's acidic. So from here we can understand this compound became stronger acid and it is interested to release H+. So acid means it releases H+ and H+ available here. Fine, this part we understood. Second part, so this is the part 1. Part 2, this is about this triphenyl Silyl. Now if you look at the bond polarity of silicon and hydrogen, this hydrogen is delta negative because of electronegativity difference, or hydrogen is relatively more electronegative compared to silicon atom. So what happens in this case, hydride will donate with its bond pair to the central boron atom because it is electron deficient sextet. So that's the reason that hydride donates. So from this thing we have understood that this is delta minus hydride, and after donation silicon will have significant amount of delta plus positive. Now just look at little carefully, student, that there is a delta minus hydrogen and from here you have a delta plus hydrogen. So these two oppositely polar, so this delta minus plus hydrogen, this delta plus, they will react together and they will produce this hydrogen gas and it will come out from the reaction medium. So this is easy. So from the alcohol side, what is produced? So from this side we are producing ArO minus, and by the way this boron reagent means this pentafluorophenyl means 3 unit containing boron is taken 2%, means it's in catalytic amount. So one side it's generating ArO minus and another side it is generating Ph3SiH plus. Okay, Ph3SiH because hydrogen has gone. So this, now what you can expect, this O minus can attack this central silicon and ultimately it produces silicon oxygen bond. This or this thing you can consider Silyl ether, means one side of this ether oxygen is silicon and another side is carbon or air. So that's why this is Silyl ether. By the way, I have already discussed many lectures about this Silyl ether preparation, so this is another strategy. So in this way what we are producing one molecule of hydrogen along with that Silyl ether. Now previously in case of alcohol to Silyl ether protection, what we have seen, we have used stronger base like LDA, and that LDA was responsible for proton abstraction process. I have already discussed, please visit for better understanding that lecture. I shall provide the link in the comment box. So this LDA was acting as a base to abstract the proton from the alcohol, means this OH. Okay, so this alcohol. So in this case this Lewis acid is activating reaction such that the hydride from this silane is capable to abstract the proton and produces hydrogen gas which is coming out from the reaction medium, and that's why reaction proceeds in the forward direction and ultimately these boron reagent remain intact. So that's why in catalytic amount of this reagent is enough to carry out this reaction. So if you look at this boron reagent little more carefully, as I told, so this fluorine has 3 lone pairs of electron and it can act as minus I and plus R because of this, and it is actually student, this is not planar, this part is in plane, other 2 units are above and below because of this severe repulsion. Okay, so this is actually a very strong Lewis acid. So what is the answer of today's question? This triphenyl silane reaction with this ultimately produces Silyl ether formation. So option this. Now this problem is little easy. So if you understand that this is actually Lewis acid, this is delta minus hydride, this is delta plus, so they will react together, hydrogen gas will be produced and this silicon oxygen bond formation will occur. Only one option I have gave this. So if you know the chemistry less than 30 seconds using this logic, you can come up to the right answer. And by the way, why not the other? First of all, option A is reduction of ester, that is less reactive compared to alcohol, so reaction will not happen here at the beginning, so option gone. Second, this is actually a, you may consider acetal hydrolysis, no water is given, this ketal hydrolysis, no water given. So how this hydrolysis can happen? And remember student, these silanes are actually reagent, they are actually, you may consider this hydrogen is delta negative, so they are polar, so anhydrous condition is always recommended for such kind of reaction. So this part is not possible. Third is both, means combination of both A and B, obviously it is also not possible. So based on your common sense you can come up the right answer, and this problem is relatively easy, but if you know the concept. Now, so in conclusion, what you have learned today, that this pentafluorotriphenyl borane, this thing is one of the very strong Lewis acid, and this is showing the minus I effect of fluorine, and it is dominant over the plus R effect because of its very high electronegativity. This reagent is one of the very promising material for first order Lewis acid base pair chemistry or FLP chemistry. Silane, the silicon hydrogen bond is associated with hydride character of the hydrogen, but the phenolic proton is significantly acidic, means opposite polarity. So this opposite polarity hydrogens can combine and produce this H2 gas. And the last one is that phenol is relatively more acidic than aliphatic alcohol because of the presence of the aromatic ring, which helps to delocalize or stabilize the conjugate base or phenoxide or oxide anion. So this is the end of this discussion. I believe this video may be useful. Please write your opinion in the comment box, and if possible, please visit my another channel. So thanks for watching. Stay happy, stay blessed. See you in my next video.